Hi, in this video, we're looking at sketching the hyperbola. The equation of the hyperbola is y equal to a all over x plus p plus q. In our example, we're going to look at y equal to 4 over x minus 2 minus 1. Firstly, we're going to draw the asymptotes. In the general form, the asymptote x is equal to minus p is our vertical asymptote, and y equal to q is our horizontal asymptote. Implementing this into our equation, our example, the vertical asymptote, change of sign, x is equal to 2. We're going to draw the line x equal to 2. And you see that we have the line, it's a vertical line passing through the x-axis at 2. That is our vertical asymptote. Our horizontal asymptote is represented by y is equal to the q value, which is minus 1. We're going to draw y equal to minus 1, horizontal asymptote passing through minus 1 on the y-axis. So we have our asymptotes. Next, we're going to find the intercepts. And reminder, x-intercept, let y be 0, y-intercept, let x to be 0. So we have our equation. To find the x-intercept, we're going to let y to be 0. So y becomes 0. And we're going to solve for x in this equation. Moving negative 1 on the other side, that will make it plus 1. And as a fraction, this is 1 over 1. We're going to cross multiply. 1 times x minus 2 is x minus 2. And 4 times 1 is 4. Or you could find an LCD and solve for that. Taking minus 2 on the other side becomes a plus 2. X is equal to 6. We're going to plot the point x equal to 6 on the x-axis. The next thing we're going to do is find our y-intercept. And remember, for the y-intercept, let x be 0. So y is equal to, where we have x, we're going to replace it with 0. Minus 2 minus 1, and we can use a calculator for this. 4 divided by 0 minus 2 minus 1. Using your calculator, you should get y to be minus 3. On the y-axis, we're going to negative 3, and we're going to plot that point. So, the value of a is positive 4. If you remember from the earlier videos, if the value of a is positive, we're looking at quadrant 1 and 3, with the asymptotes representing now the axis. So we have, or this graph will be drawn in quadrant 1 and 4. So we're ready to sketch our hyperbola. So we're looking at a hyperbola cutting through minus 3, gentle curve. And on this side, our hyperbola will pass through 6. If you want an accurate point, you can take a random value on the x-axis called 4, and you can substitute 4 into this equation, and you'll get the corresponding y value. Similarly, in the same way, if you want a value on this side, you can take any value like x to be minus 2, sub it in the equation using your calculator, you'll get a corresponding point. So we're looking at the hyperbola, y equal to 4 over x minus 2 minus 1. And now what we want to do is look at the domain of this hyperbola. Your domain for x is allowed to be anything. X is an element of reals except the asymptote. And in this case, we're looking at the asymptote, which is minus p. So implementing that in our example, x is an element of reals and x is not equal to positive 2. So that's our asymptote, 2. The range, in the same way, y is the element of reals, except y is not equal to the asymptote, the y asymptote. And if we implement that, y is the element of real, y not equal to negative 1. Now, we talk about an axis of symmetry, a line that cuts the hyperbola into 2 equal parts. The hyperbola has 2 axes of symmetry. There's our first one, cutting the hyperbola into 2 equal parts. And you'll notice we have a straight line with a positive gradient, increasing function. Or we can draw an axis of symmetry the other way with a negative gradient. So the axis of symmetry has an equation because the gradient can be either positive 1 or negative 1, the axis of symmetry will be y equal to x plus c, and that is the line which has a positive gradient, or y equal to minus x plus c. In this video, we'll find the equation of the axis of symmetry with a positive gradient. So we're going to use y equal to x plus c, and all we need to do here is find c by substituting a point on the line or the axis of symmetry. And if we go through this line, you'll notice that the line will pass through the intersection of the asymptotes, and the asymptotes intersect the x-axis 2, the y-axis -1. So they intersect at a point called 2, -1. So we're going to sub that point in. Y is -1, x is 2, and that will allow us to find c. Taking 2 on the other side, we get c to be -3. So our equation would be y equal to x minus 3. And you'll notice that it is a line with a positive gradient of +1. In the same way, we can go find the equation of the axis of symmetry with a negative gradient. Thank you.